Dr. Bhaskar Choudhury is going to be talking about his dry eye device.
Thank you, Dr. Namrata, for inviting me. So I'll be talking about a little bit of technology after all the clinical presentations and about a novel multiparametric dry eye diagnostic device that we have developed. So we are, while we are not moving away from the core tests like Sharbat test and tear breakup time and surface staining, there are a lot of tests which have evolved for diagnosis and gradation of dry eye, particularly the evaporative type. And there are quite a few devices on the market like LipiView, Hydra, Keratograph, MeCheck, etc., etc. So what was the necessity of devising another device? Is it reinventing the wheel? So the major shortcomings that are there in the existing devices are that they do not give a complete data about lipid layer thickness from the central cornea. Only the inferior periphery is done. And why is that important? Because the central cornea is responsible for vision and what is now being called functional vision. So that is a function of the central corneal tear film dynamics. Also, we do not get a detailed blink analysis, only complete and partial blinks are available, whereas the important parameters that are evolving in blink analysis are the interblink interval statistics and the lid contact time. Also, it does not show the actual meibomian gland segmentation, these existing devices, and only gives out a number. So there is no way to verify whether the segmentation, which is a complex process, has been done properly. So with that, we started developing this device about 4 years back to do a central 5 millimeter lipid layer thickness mapping, a detailed blink analysis, meibomian gland segmentation with calculation of meibomian gland area and loss, and lower tier meniscometry. So what we are getting now are shown on the top. That is, you get a small part of the inferior mid-periphery of the cornea where the lipid layer is analyzed. Whereas what we want is shown in the lower part, which is the central cornea. And here's a small video from our device in which you can see that other than the abnormalities of the average lipid layer thickness, it is very important to look at the lipid layer distribution, especially across the blink. So if there are clumps of lipids in the central cornea or paracentral cornea, even after a blink, so that is an indication of evaporative dry eye. This part of the video you can also see what happens if you put parakin which contains BAC and how it clumps up the tear film lipid in real time. So this was achieved through the development of the lipimetry attachment, which is a specially designed patented acrylic cone which gives a large uniformly illuminated Purkinje 1 image from which the lipimetry analysis is done. So we give out the report, which will be shown in detail later on a scale of red to green, and you can easily see where the patient is in the spectrum of lipid layer thickness. And also, as you can see, the color-coded maps are provided, which gives easy readout for the clinician. One important statistic that is emerging in our studies is the ratio of the thickness of the upper part of the central corneal lipid layer and the lower part of the central corneal. There is the upper to lower ratio. And if it is less than 0.75 or more than 1.25, it usually indicates clumping of the lipids in one zone. Something similar is done with the keratograph, but you don't get a continuous image. There are no colored things provided, and it gives out only one lipid layer thickness. So with this device, we are also challenging the conventional teaching that the two lids have to come in contact to spread the lipids from the openings of the meibomian glands. So here is a case of Bell's palsy, in which you can see that the lids are unable to close completely. And if you observe, even in spite of that, the lipid layer is being pulled up from the lower part of the cornea. So with this device, with the central lipid layer mapping, we will be coming across many interesting statistics and many interesting studies in the future, I am sure. So we go on to blink analysis, and this is done using infrared illumination, so there is no stimulation by incident light. And there are about 700 to 800 frames grabbed over a 30-second period, which are analyzed and converted into a one-dimensional array against time. And from the array, you can get the blink completeness, you can get the interblink interval statistics, you can get the lid contact time and the blink duration, all from this, and it gives out a quality factor which is color coded over here, so you know whether the blink acquisition has been accurate. And once again, like the rest of the report, it is put on a red to green scale so that you can know where the patient stands exactly. Meibomian gland analysis, one of the most difficult part of photographing meibomian glands using infrared is that you don't get good contrast images. You get low contrast images. So in this device, we have introduced an algorithm in which you can see the high contrast enhanced images in live view so that you can capture good quality images all the time. And once you have captured and selected an image, then you have to mark out your area of analysis or the region of interest, and it does an automatic segmentation of the meibomian glands, which you can verify from the diagram. And it has been seen to work in different situations like tortuous gland shortening, overexposed images, unequally exposed images, etc. We are successfully able to segment out the meibomian glands and measure the area. Meibomian gland segmentation report is given out as the loss percentage, because that is what is working in the industry right now. So on the pulled scale, a loss percentage is given out. Meniscometry is done using infrared, and you have the option of measuring the meniscus at whichever point you want, and the acquisition is automatic when the quality parameters are met. It is really a very simple thing, and it measures the radius of curvature of the meniscus. So it's a reflectometry based technique and automatic capture. So we also proceeded to validate the device, and we did two sets of validation studies. One was the intra and inter-observer validation, and another was head-to-head analysis with IDRA and LipiView. So in the intra and inter-observer validation, we did 40 eyes, 3 observers, each taking 2 consecutive observations. So we had 240 data points per test, which is a fairly large series. And in the LipiView and IDRA, we had 28 eyes in each series. We did an ANOVA for establishing the variability, intra and inter-observer variability, both came out to be good. In the head-to-head LipiView, we also did an ANOVA as well as a Bland-Altman plot, and as you can see in both LipiView 2 and IDRA, the comparatives are good. So the device comes in 2 form factors right now. One is slit lamp pluggable, so you can bayonet fix it in the centering hole of the slit lamp, and it also comes as a standalone unit, which is a separate device with its own computer. So the reporting format is like that. It's 1-page compact report which gives you the relevant diagrams, the lipid maps, as well as the different parameters which are on a scale of red to green. So to conclude, we have been able to do breakthrough central lipimetry live at 10 frames per second, color-coded thickness map for easy identification by the clinician, an in-depth blink analysis which includes lid contact time and interblink interval, focus assist in mammography to capture the perfect image every time, fully automated gland segmentation and loss area calculation, and a very compact form factor which is space saving. So now we are going for wider validation studies which are multicentric, and we are waiting for regulatory approvals by the DCGI. Thank you.
Congratulations, Dr. Bhaskar. It's a, I think, very nice and useful device. One question, has it been patented? And second, is it available? And most of the panelists are interested to know what is the cost also.
Cost, it is not for me to say. It will be marketed by medical device company. So we have entered into an agreement, and they will go through a process of cost discovery. So probably they'll come to you and ask you what should be the cost of the device. But definitely one of the purposes of designing and developing this device was to bring the cost down from the range of 15 to 20 lakhs to sub 10 lakhs. That much I can say. Is
it patented?
Yeah. So it has got two parts. One is the hardware, which has to be patented. The patent has been applied. It's in process. In India, patents take somewhere between 4 to 5 years to be awarded. And the software has been copyrighted. So we have copyright for that.
Great.
Excellent device. One thing I wanted to know, why have you confined yourself to the central part of it? If a patient gets a dry spot in the peripheral part, will he be symptomatic or not?
So if you see, Dr. Bose, we have not done NIBUT, although all these kind of devices do NIBUT, because when we started analyzing the NIBUT attachment, what we found was that the central cornea, the central 4 or 5 millimeters of the cornea behaves completely different from the peripheral cornea. And you also have to realize that the central cornea has the richest density of nerves. So that is the area which the body also controls very, very tightly. So we gave up doing NIBUT halfway down the track because we found that the central cornea, the Myers would not break down. All the breakups that you see in tear film are mostly in the peripheral cornea. Even if you see the ultra short breakup times, they are also in the peripheral cornea. You will rarely find them in the central cornea. And how important they are, we do not know. The one single thing that is emerging from whatever studies we have done, although we have not right now in a position to publish them, is the abnormal distribution of the lipid layer thickness in the central part of the cornea is a definite determinant for evaporative dry eye.
Thank you. Thank you so much, Dr. Bhaskar, and wish you all the best.